Greetings to Dr. Nuliana. We are from Group 5 going to present a proposal of flocculation experiment with my members of Chan Yong Sun, Edelin Emirra, Nor Faradiba and me myself, Richard Wong. The environmental pollution is becoming severe. Therefore, water treatment plays a crucial role in ensuring clean water sources for consumption. Hence, study is needed to optimize several factors to remove micro and macro particles from the water. In this case, it will be the coagulant dosage and the mixing speed during coagulation. There are several objectives in this experiment, which are to study the effect of coagulant dosage and the mixing speed on the sedimentation process. It is also to study the effect of coagulant dosage and the mixing speed on the pH, color, and turbidity of the wastewater sample. And finally, it is to study the wastewater treatment processes that consist of coagulation, flocculation, and sedimentation. The manipulated variable in this experiment will be the coagulant dosage on the wastewater and the mixing speed during the coagulation of wastewater. The responding variable will be the pH, color, and the turbidity levels of wastewater after the water treatment process and the efficiency of the turbidity removal. And lastly, the constant variable will be the mixing time and the concentration of the coagulant.
Next methodology. So the first sampling procedure is 7 liter of wastewater sample is collected from the water sample from Sungai Tuang, Kota Samarahan. 3 gram of aluminium sulfide is added into 500 ml of water to produce aluminium hydroxide solution. Next experimental procedure. So for part A, coagulant dose, 500 ml of wastewater is added into 6 beaker. Record the initial pH of the wastewater for every beaker using pH meter. Adjust the height of the stirrer to the maximum by adjusting the wing nut bolt. Add 1, 3, 5, 7, 9 and 11 ml of aluminium sulfate into beaker 1, 2, 3, 4, 5 and 6. The height of the stirrer is lowered until reach the half height of the mixture and turn on the stirrer for 20 minutes at the rapid mixing speed of 200 rpm. Then wait for another 30 minutes for the flock to settle in. Record the pH, color and turbidity of the solution and the height formed by the flocks. Calculate the percentage of turbidity removal using the formula as follows. For part B, which is involve rapid mixing speed, repeat step 1 until 3 in part A. Add 5 ml of aluminium sulfate into 6 different beakers. The height of the stirrer is lower until reach half height of the mixture and turn on the stirrer for 20 minutes at different rapid mixing speed of 50, 100, 150, 200, 250 and 300 rpm for beaker 1, 2, 3, 4 and 4, 5 and 6. Wait for another 30 minutes for the flock to settle in. Record the pH, color and turbidity of the solution and the height formed by the flock. Calculate the percentage of the turbidity removal using the formula as follows.
This data table will be developed to describe the effect of coagulant dosage on the performance of coagulation and flocculation processes. The pH, color, turbidity of the solution and the height formed by the flocks will be recorded. Then, the percentage of turbidity removal will be calculated by utilizing the formula as has been mentioned in methodology. This data table will be developed to describe the effect of rapid mixing speed on the performance of coagulation and flocculation processes. Record all the required variables and make a calculation on the percentage of turbidity removal. Both figures show the expected results regarding the turbidity removal, which is influenced by the factors including the coagulant dose and rapid mixing speed respectively. As shown in the left figure, there's a peak which indicates the optimum dose of coagulant, which is then referred to the minimum dose used in which the maximum turbidity removal is achieved. While in the right figure, for various settling times, as the rapid mixing speed increases, the residual turbidity decreases, which indicates that the turbidity removal percentage increases.
The following safety precautions precautions need to be followed when handling these chemicals. For aluminum sulfate, we need to ensure adequate ventilation and do not flush it into surface water or sanitary sewer system. When handling aluminum sulfate, make sure to avoid contact with skin and eyes. Thus, wear appropriate safety goggles, gloves, and clothing to prevent skin exposure. The chemical waste generator must determine whether a discarded chemical is classified as hazardous waste. Next is water. For water, it is classified as non-hazardous chemical, but we still need to wear protective gloves and goggles and reuse or recycle the waste whenever possible. Lastly, aluminum hydroxide. We need to avoid inhalation of dust, thus when handling these chemicals, wear safety goggles, gloves and mask. Make sure to not mix it with other waste when disposing aluminum hydroxide. That's all from us. Thank you.